Hello everyone, welcome to Process Control. I am D. Devasigamani, Assistant Professor, Department of Electronic Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to see about piping and instrumentation diagrams or P&I diagrams. Here, we will discuss piping and instrumentation symbols and diagrams and how to read P&I symbols, equipment identification, tag symbols, instrumentation symbology, software and sources, and some exact P&I diagram illustrations and its limitations. P&I diagram is also known as process and instrumentation diagram. It's a graphical representation of process which includes all details of a process control plant. P&I diagrams are very useful in industries, especially for process control and chemical industries, in order to identify the instrument locations, sensors, and control functions, which ensure better understanding of plant. It shows the interconnections and interconnectivity of pipes, instruments, and its equipments. In simple, it is a schematic representation of all process equipments and its piping in industry. In addition to that, P&I diagrams are used to train the workers also. It has a set of rules and guidelines given by ASME, American Society of Mechanical Engineers, Instrument Society of Automation, and American National Standards Institute. Let us discuss in detail. In general, P&I diagram is a symbolic representation of all process in industry. It shows all piping connections, it shows all valves, it shows all instrumentation means like transmitters, controllers, and actuators within a single diagram. Here, this is the schematic representation of a heat exchanger model. In the left-hand side diagram is a process flow diagram of that model. It includes all the main components and their process in very clear way. And the right-hand side is a modified form of the process flow diagram. This is what exactly called as P&I diagrams. So it is a simplified form. Here, every equipment is represented with the help of symbols. These are the characteristics of P&IDs. P&I symbols are grouped up by specific sections. It's a schematic representation. It's very clear, easy to understand. It's a systematic one, usually confidential, does not disclose to any unauthorized person. It's revised whenever the revision is needed. It's often revised, and it's based on AZUB. AZUB is nothing but hazardous operativity analysis. It's mainly a safety based. Of course, P&I diagrams can fulfill the industrial safety aspects. These are the elements of P&I: equipments, valves, instrumentation types and locations, communication between the instruments, and piping sizes. These are the different type of chemical process diagrams used in industries. First one is block flow diagram. This is something similar with the block diagram approach in control systems. Here, each and every process is represented with the help of blocks and its sequence. And the second one is process flow diagrams. Process flow diagrams includes all the main components and their process flow. It has a set of sequence and their flow chart. And next one is piping and instrumentation diagrams, P&ID diagrams. So P&IDs is originated from process flow diagrams. It has a set of symbols and rules. All the process has been represented with the help of symbols with tag numbers. And next one is utility flow diagrams. All the process control utilities has been clearly identified in these diagrams. These are the supporting documents which are needed to prepare for P&I diagrams. First one is process flow drawings. It includes all the information in industry from input level to all the sequence input level to functions, all has been arranged in this order. Then material specifications, equipment, instrumentation specifications, functional requirement specifications. So these are the documents which are needed to prepare for P&I diagrams. It gives what are the details to show and not to show in P&I diagrams. The details like equipments, instruments, materials, piping, valves. So these details can be shown in the P&I diagram, and the other details like process information, physical dimension of equipment, piping details, and control logics. These and all we cannot disclose to in P&I diagrams. These are the P&I symbol contents. It has three major categories: equipment symbology, piping symbology, and instrumentation symbology. This is what the identification of equipments. In P&I diagrams, equipments are represented with the help of circles, letters, and numbers. First of all, we must learn letters indications in order to identify all the equipments clearly. Basically, it consists of three letters. The first letter is used to identify the process variable like pressure, level, and flow and temperature. The second letter indicates the readout functions like alarms, recorders, and functions. And third letter is used to indicate the output functions, which means a controller and transmitter, like that. And some designers may use 4 to 5 letters also. And the number is the representation of tag numbers. So this number is changed to each and every instrument from the designer voice. And the next one is line. Line is an important symbol in equipment identification. Here, lines are mainly used to identify the location of instruments, whether it's been available in near or far from the operator. And consider the first symbol. This is a circle with no line, which means the instrument is mounted in the field near the process, that is close to the operator. And this is the circle with solid line, which means the instrument is mounted on the main control panel itself. And if it's in dotted line, means the instrument is far away from the operator. It cannot be accessible. It may be situated in some hazardous conditions. In industries like nuclear power plants, thermal power plant, they used to represent the symbols like this. And this is mainly used for shared display options in DCS control, distributed control systems. It's mainly used in DCS. Yeah, of course, in DCS, all the informations from sensor and transmitter can be shared via servers in order to act DCS as a master controller. Of course, DCS can be represented with the help of squared and circles. So this is the representation of DCS, squared and circles, and with the help of shared display options. And all the remaining logics are same. If it's no line, means it's available in the plant. If it's single line, means it's in the control room. If it's dotted line, means it cannot be accessible by the operator. These are the different tag symbols and tag prefixes with some IDs. And there is one more identification symbol is there. That is a circle with double lines. That is axillary location, which is available in nearer to the operator. It's mainly used for remote monitoring applications as well as wireless based applications in an industry. And if it's dotted line, means it cannot be accessible by the operator. These are the different type of interconnections that are used in P&I diagrams. Normal line is a representation of all process connection. If it's dashed line, which means that is in the form of electrical lines. So the pneumatic lines is represented with the help of line with double slash. And these two, electric as well as pneumatic lines, are mainly used to represent the controller functions in the P&I diagrams. This is data link connections, and this is hydraulic link connection, and this is what electromagnetic connections of an application. These are the different lines and joint fittings that are used in P&I diagrams. Control valves. See, control valves are integral part of all instrumentation systems. There are more number of valves available. Control valves mainly used to control as well as regulate the fluid flow in the system. There are more number of types like three-way valve, two-way valve, gate valve, check valve. All these type of control valves are exactly represented in P&I diagrams for specific applications. These are the different symbols that are used in P&I diagrams. So this is what the exact instrumentation symbol of equipment. This is FIC. FIC is nothing but flow indicating controller with the tag number of 55, and the line represents the instrument is mounted on board. It's mainly used for flow measuring process, and the remaining controllers are also available in this chart. That is pressure recording controller, PRC, and PIC is nothing but pressure indicating controller, flow regulator, flow transmitters. So that we can easily identify all the equipments in a very convenient way. So this is what exact picture of industry where the sensors are located in a field. So here two sensors are displayed here. One is a pressure sensor, another one is a flow transmitter, which is situated in bottom of the pipe. And these are mainly used to measure the pressure as well as flow rate. So these can be easily represented in the diagram with the help of a single line. And these are the instruments that are board mounted. So these are the control boards which is mounted in this plant, and this can be also explained displayed with the help of circle with single line. And this is the instruments that are mounted but invisible to the other persons. This also represented with the help of circle with dotted lines. And this is the representation of CPU and IO symbols. In P&I diagrams, all the computers and computer-based instruments are represented with the help of squares and diamond symbol. And this is a representation of PLCs. Nowadays, PLCs are more familiar. It's been used in all type of industries for their applications. Here, this is the representation of a PLC that is squared with diamond symbol, and this line and this number COT is a representation of what type of signals to be used, whether it's analog or digital signal. And this number is nothing but the loop number, and this is IO number. And this line indicates whether the PLC is accessible or not. And these are the various fields that use the P&I diagrams. And these are some of the softwares and sources that are used to draw the P&I diagram. AutoCAD P&I. So this is familiar for mechanical and chemical engineers. Aviva, ePlant, SmartPlant, Lucidchart, Desktop, Microsoft Visio. Of course, Microsoft Visio is useful for mathematical expression, and some online engineering toolbox also available to draw the P&I diagrams. So these are the some exact P&I diagrams of industries. So once we learn P&I diagrams, we can easily understand all the processes. We can easily identify where the instruments are located by seeing this diagram itself. Now we can easily analyze this chart. So here more number of valves are presented. So this is the control valve. So these are the control valves are used here, and this is the tank, and this is level gauge, and these dotted lines represent electrical connections, and this slash lines is representation of pneumatic connections. So these are the pneumatic connections that are used here, and this is a flow transmitter, and this is a flow control valve and pressure gauge. So like that, we can easily identify all the equipments by seeing this diagram itself. And this is the exact picture from industry, petroleum industry. The process is a refinery process. Here, it consists of more number of sensors and valves and a transmitter. Of course, this is a vertex flow meter. So all these sensors and instruments are exactly represented in this diagram. So by seeing this diagram itself, we can easily identify all the process for better understanding. And this is the P&I diagram for a reactor system. So this is the reactor mixture. It accepts 4 different type of reactants. Based on that, it can provide the output. Apart from this, it has more number of sensors and transmitters. So all can be exactly pictured out here, so that we can easily understand all type of process by seeing this P&I chart alone. And this is the P&I diagram for Benzene distillation column. It's one of the complex process in chemical industry. Just see the diagram, how it's been complex one. Anyhow, it's complex. We can easily identify all the components, all the components and diagrams by seeing this P&I symbol alone. Even though P&I diagrams are very useful to us, still it has some limitations that are P&I diagrams cannot rely on exact model of process. It can be changed from dimensions and geometrically it's not equal. And second thing is standards. P&I diagrams cannot be equal standards. It may be changed from designer to designer, and company to company it may vary, which limits the validity of P&IDs. These are the references. Instrument symbols and identification, ISA, chemical engineering process, and instrument engineer's handbook. Thank you.